What is going on, guys? I hope everyone's having a great evening. It's a beautiful night in Tennessee, as always. Thank you once again for stopping by. If it's your first time, my name's Paul. This is my channel. I'll be your host for the next 15-20 minutes or so. This one might run a little longer. I was blessed to be able to take a tour with Cameron Weiss at Weiss Watch Company, formerly of Los Angeles, California, now making their home in Nashville, Tennessee. And yeah, it was really a cool experience, enlightening experience to say the least. While I didn't really take the tour for you guys, I pretty much took it for myself. I wanted to see the shop. I wanted to see how things were done. Then I decided I wanted to upload it here for you guys so you guys could see what goes into Weiss watches and why he really should be held as one of the premier watchmakers out of the US. So if that sounds good to you, let's get right into it. First, I've been trying to figure out how I was going to present this because, like I said, it's a random video. I did need to cut it down because we were there close to 3 hours. So I thought what I would do is sort of tell you what we were going to look at and then just have Cameron talk about what we're looking at. First up is a machine that he purchased a couple of years ago. It was running in another state and he just had it shipped here to Tennessee to make his cases on site. This is a gigantic milling machine. He's making his cases in this milling machine. He created the program himself to cut all the cases that Weiss Watch Company makes. The machine does all the work, cutting all the sides in one go around. He says once it's set up, it takes about 15 minutes per case, which is fantastic. Get a number of cases off of a 6-foot bar that he runs through this machine and then puts another bar in for more cases. So let's take a look at that machine now. I should mention too, it took me a second to get the sound levels correct, so the volume will level out here in just a moment. Just give it a few seconds.
Milling and turning everything all in one operation here, so I don't have to set things up and move them around. Anytime you take a part out of a machine, these are robots, right? You have to then teach it exactly where that part is now located in space and where all the tools reflect with the part, right? Otherwise things are going to crash into the part and damage it.
Will that significantly improve waterproofing, for example, the tolerances for how you need everything to fit together, or is that all fairly fine?
It can. I mean, because we can dial things in to much tighter tolerances. Right. Having the machine here, as opposed to the machine being on somebody else's floor, right? We might say, hey, buy this special tool because we know we're going to use it a lot, and it's going to be way more accurate than the way a job shop would use a general tool or something, right?
Okay, so that is the all-in-one milling machine. He does have another milling machine that we're going to look at now. It's a much smaller mill. It's a more standard milling machine. This one makes cuts, resets the machine, makes more cuts, resets the machine, makes more cuts. Very similar to how you would do in woodworking and other industries that use cutting tools. So let's take a look at that.
It's just a regular mill. So you just have end mills and drills and things that come down, and a table side to side, front and back, and obviously with a side to side and forward back motion combined together, you can make circles, right? So in here, this is a much smaller machine, has a tiny little footprint. We place our parts on here, we clamp them down to the table, they're fixed, and then we make our cuts on one side of a part. On that machine, we can cut all sides of the part without unclamping and reclamping. And that's the huge benefit, right? Because we have features on the front of our part, we have features on the back of our part, and we have another side where we have to drill a hole to a really tight tolerance to make sure that it's water resistant. So the way that we work on this machine is a bit different. We have a pallet. I'll show you the pallet back here. The pallet. And this is what we clamp on the table, right? And then we can cut just on one top side of these brass squares. So we cut on the top. Then we take our part out of that pallet, and we have this other pallet. This is the second operation here. So we drilled, or actually we used an end mill to cut those holes, right? So then we will unclamp the parts when one side is cut, unclamp them, flip them over. So this one you can see has just been started but not finished. I have a probe that will probe those holes so that we can recalibrate every single plate. Because if you take a part out of a vise and you try and put it back in a vise, no matter how nice your vise is, no matter how perfect your parts are, it will never go back in the same way that it was before. So we take measurements off of those two holes on every single plate with a probe. Then we run a macro program in here, which will actually recalibrate all of the coordinates in our program for every plate individually. We'll go through, cut every one of the second sides. It's held on by tabs, tiny little tabs there. And then we can break it loose, like that, right? So you can see the first side was cut on this one, and then we cut the second side. So the final thing we have to do is cut the third side, where we actually drill a hole for the winding stem to go through the side of the movement. So that needs to go there. There's a little tiny square that's already been milled, but we need to open it up so that it's round and in exactly the right location to match up with the case of the watch.
Okay, so this machine makes crowns, winding stems, screws. I can't believe he makes his own screws, but he makes his own screws for the movement, and he also makes his own screws for the cases, which I questioned in this video, and the explanation made total sense. So let's check that out.
So this is a 4mm bar right here, and that's as big as this machine will cut. Just a 4mm bar. You can kind of see on the tip of it right there, there's a screw, or at least the start of a screw that hasn't been cut off, right? Chop it off, finish the top side, which would be the slot in this screw. Then more bar comes out, we cut another screw. They're called sliding head lathes, or also known as Swiss machines, because they were developed. The Japanese will say they developed them, and the Swiss will say they developed them. I don't know who was there first, but this is how tiny little watch parts are made on this style of machine. Tiny little part being cut off the tip though, so a 6-foot bar
Other than just being like in-house, what's the benefit of making your own screws as opposed to just buying them?
We make the bridge, right, or we make the main plate. So we're the ones doing the threading.
Right.
So we're also the ones making the screw. So if I want to change something for good reason or not for a good reason, just because I want to, right? I can do it. I can also make sure that our things fit better, right? We can have a better fitting screw because we're making both parts.
Makes
You
sense.
won't find anywhere in Switzerland where you can get a main plate and a screw in one workshop. This is where those come out. They'll come out into these little trays. You see all that oil? That's the cutting oil.
Does this use the same oil filtration process? That machine where it goes through the different
Slightly different. I'll show you once it's done cutting how we kind of manage the chips and the oil. Actually, so the way these programs run, this will just keep cutting screws, right? It'll just keep going and going and going and fill that up. What I did is I put a stop on there. So when it gets to the next one, I think it'll be halfway through one screw and it'll stop. So that's the cutoff tool, which makes the horrible noise. Yeah.
Okay guys, so he has two of those machines doing different parts for each watch, but he also has a industry standard when you're talking about Swiss watchmaking in the factory as well, and we're going to look at that now.
Version of the CNC lathes I have there. So this is the same company, Tornos, out of Moutier, Switzerland. This has one motor, belt driven, camshaft in the back. The camshaft has these cams that interact with the arms here to push all the movements of the machine. So if you want this, let's say, this cutting tool right here to cut into the part, you need this arm to move side to side. So you have a cam over here on the shaft that's spinning to push, right, with a load on the other side of that arm here. So I can spin this manually, it will run a lot quicker with a motor. And you can see that camshaft turns and the tool is moved. So instead of programming on a computer, you actually program by designing cams. These cams. Load up the cams on your camshaft. And that's a pretty complex move right there. You see that? How that moves that drill? So this can get very complex. It makes some really complex parts. And then once it's all set up on there, you can adjust. You can do fine adjustments on every tool. This will make parts quicker than a CNC machine.
Right.
And that's because all of the movements are quicker. They're direct instead of being an electric motor with screw drives. Right? These are just pushed forward by a load on a spinning shaft. Whereas the other ones you have a screw and the screw has to turn. So the screw has to speed up and get to speed and then slow down in the movement. So this will actually make more parts in less time.
And then we get into where he takes a closer look at the movement pieces that have just been produced and that sort of thing.
So you can see how dirty this part is. all these little dust particles and things. This is an escape wheel, right? So there are certain things we want to check on this escape wheel to make sure that when we actually put it in a watch, it's not going to lock up on one of the teeth. We need to make sure that these heels are concentric, right? If the heel deviates too much as it goes around the wheel, one might lock up. So we can grab points on a certain number of heels or all of them, and we can use the computer software to actually measure it and make sure that that's concentric or within a certain tolerance to the center hole, right? Where we're going to put the pinion that was made on that lathe over there. So the dials I contract out to somebody. So they'll make we actually use a certain bronze for the dials, similar to a brass, but that will then be sent to New York, where I have a painter who paints them and then prints them. When we first started out, I did the paint and the printing, and it was not fun for me. You engrave a plate. You take a metal plate or a ceramic plate, and you actually etch in the negative of what you want. So you cut away material, and you have a cup that goes over that. It's full of ink, right? So you fill your ink cup, you have your plate, you put your plate on top of the ink cup, you flip that over, it goes on a machine, and that ink cup will go back and forth, and it will deposit ink into what you engraved, and then take away the excess as it comes out like a squeegee. So you move that ink cup over the engraving and then back away. Then you have this on a special arm. This is a silicon stamp. You move that down, and the top side of the ink that's exposed to air becomes tacky. It's more tacky than what's not exposed to air that's in the engraving or the etching. So it will stick to the silicon. So you can see from all of the dials I made our logo and the numbers and everything that we would stamp.
Okay guys, before heading back to the studio, I want to know in the comments, what's your favorite dial color for the Weiss Watch Company? For me, I think it might be yellow. From there, we get the finishing of the cases. He talks a little bit about some of the tools he uses, that sort of thing. My cat decided to join us. This is Buddy. Say hi, Buddy. All right, you can get down. But yeah, really, really cool. We're looking at the finishing here. And that'll about do it for this episode.
All the hands are pressed by hand, so each hand is pressed by hand on the movement, friction fit. All the screws screwed by hand. There's no electric screwdrivers. There's no electric presses. I have some things like this that I can set up that help me do things. Like I was casing up, so on this particular stem, this helps me cut the stem to the exact same length, since we're doing the same watch over and over again. So that it'll fit properly with our crown. Not only does it make assembly quicker, but I scrap fewer parts. Everything's very specialized, and it can all be done in an old school fashion. But since we're making the same watch over and over again, it's worth it to machine special tools and get special presses just for a certain watch, because I will do the same case to 100 times. What's your typical match? Our matches are usually about 100 to 500, depending on the part. But I will go one at a time. I will finish one whole movement, assemble it, and it'll go on the winder to make sure that it runs through the night. It's a manually wound watch, but we want the wheels to fall into every position it possibly can fall into, and we want the hairspring to be in a bunch of different positions to make sure that it keeps time over the course of the line. Right, as the line goes down, it becomes less accurate. want it to keep time, if I see that it's way off, I know that maybe it's stopped, right? Maybe it's stopping every time it's dial up, and that means there's some kind of friction there. Use that test to tell the accuracy over a period of time and to make sure nothing's binding up. We can't put it on a machine like this one. This will give us an instant reading of exactly what the seconds per minute of the watch is in every position, right? And this one's automated, so I can just hit start, and this will actually automatically rotate the watch head. It'll measure it dial up, it'll flip over, it'll measure it dial down, it'll measure it crown up, crown down, 3 o'clock, 6 o'clock, and do all of our positions, take the measurements, and I can go print out, or I can just look at it. I have, for the watches we work with, programmed in there with tolerances. So I can just look over here, and see if I see red check marks, that means one of the positions is not there. Super precise measurement. We'll close the case. It will put a vacuum in that chamber and try and suck air out of the watch case. If the case leaks, it will not change in dimension, right? Air will just come out of the watch. If it is sealed, when you put a vacuum in there, the crystals will pop out a little bit, right? So it'll measure that deflection. When you pressurize it, same thing, it's going to try and push air into the case. And we can do 10 bar on here, which is a scary amount of pressure when you're dealing with air. That pressure, if you have a leak in the case, it will go into the case. And then when it releases the pressure, your watch will explode.
When you say explode, like it'll make some noise in here and shatter, or like the entire machine will fly?
The machine will not explode, the watch inside will explode. It's just like a total loss, pretty much. The air pressure goes into the entire watch, it goes in your mainspring barrel, and it cannot escape the barrel quick enough. So your mainspring barrel explodes inside the movement, right? So now your movement parts are all bent.
Can you guys imagine spending that much time creating this case, creating this movement, creating this beautiful piece of engineering, and then just have it explode in a tester? That's a horrible situation. We mentioned all the things he makes here, watches, watch cases, watch bracelets, but he also does these watch changing tools out of brass on those lathes we just looked at. And I did mention bracelets. The dive watch he is just producing now has a bracelet option. One of the cool things on this bracelet is the screw links are on every single link, not just a few links, but every link on the bracelet has a screw adjustment, which makes this bracelet better than so many out there. Okay guys, so I know this is a little different for the channel, but I went to the tour, videoed some of the tour, thought it was really, really cool, because quite frankly, I sort of expected to watch him assemble a watch that had already been sort of produced. I had not fully understood how much that he actually produces on site. Hope you enjoyed. Check out Weiss Watch Company in the link below. Check out all my links, and yeah, we'll just see you soon. I'm pushing to 3,000 subscribers, so hit that subscribe button if you haven't already. And hope you have a great night. Peace.